Multiplying and dividing rational expressions. So in 7.1, we basically looked at what number in the domain, which is 4x, which merely, if it's on the bottom of a fraction, what you can not allow x to equal. And then we also looked at simplifying rational expressions. So in the next section, we take it up a notch because I did mention to you guys we're going to do all the operations. So we're going to first look at multiplying and dividing rational expressions, which is really how you reduce within to actually multiply two tops and two bottoms, okay? So we're going to take it really small, taking it back to just some basic fractions first. If you were to have 4 over 9 times 15 over 16, and granted, when you're multiplying fractions, it's just merely top times top, bottom times bottom. But to help your numbers from not being so big in the end, you can reduce within it, okay? And that means any top with a bottom. You can go up and down, or you can go diagonally. If they have something in common, you can cancel, okay, or reduce it. So we do know that 4 and 16 have something in common, just as well as 9 and 15, okay? So I'm going to say that 4 will go into itself one time, but it'll go into 16 how many times? 4. Very good. And then I'm going to reduce 9 and 15. Now, 9 doesn't go into 15, but what do they have in common? A 3. Good. So you divide by 3. 3 into 9 would leave you with 3, and 3 into 15 will leave you with 5. Very good. So now multiply. Now some students rewrite it so they can see exactly what they have. You can do that, or you can just look at it if it's not too messy and just multiply top times top, bottom times bottom. So 1 times 5 will give us over 12. Good. 3 times 4 is 12. And that just helps from you not having to actually reduce whatever 4 times 5, which would 15 would be, which is what, 60, over 9 times 16. That number might be a little bigger. So that's the reason why we reduce within. Do y'all remember reducing within? Now let's add some variables. If you were to have, let's do 15x squared over 14 times 7 over 5x. So it's the same concept. If you can cancel top and bottom, either up and down or diagonally, that's what I would do first. So with 15 and 5, 5 will go into both. In the 5 one time and 15 3 times. And then 7 and 14, 7 once and 14 2. Good. Now, because I have a big handwriting and I can get real messy, I would now just rewrite or write what I have. I wouldn't cancel my variables right here because you might mistake an exponent for a number. Does that make sense? So I would keep that as 3x squared is what's on top. And what's that, a 2x on the bottom? And then I would reduce my exponents. Does that make sense? My variables. I wouldn't kind of cancel it within it because you might mess it up. So now, what's the rule if you got the same base in division with exponents? You do what?
The greater one.
But what do? You subtract them. Good. That's the rule. It's to subtract. Yes, you'll put your answer where the biggest one, which would be on top. Very good. So we would have, what, 3x over 2? And that's our answer. Because 2 minus 1 just leaves 1. Does that make sense? Yes.
I was wondering that too, but I see what you did. You multiplied it. Oh, okay. Sorry.
Yeah, I thought y'all was following me. You multiply whatever's left on the bottom. Now, if you want to rewrite everything, you can take the time to do that step. I normally don't if I don't have a big mess right now. But if you rewrite it after I've marked everybody off, do you see you have 3x squared on top of 2 times 1 on top of x? So now you see where I get 2x from on the bottom. Okay. Any other questions? Number 3. Four over 5 divided by 13 over 20. Now division has one slight difference from multiplication. They work the same way though, but you gotta be reminded that when you're doing division, that you have to do what? Flip which one? The second one. Make sure you flip that second one. Good. First one stays like it is, but you make sure you flip the second one. So you would have 4 over 5, and once you flip it, it changes to multiplication. Times 20 over 13. Do y'all see that? It's just a mere flip. And then you do the exact same process. You see diagonally or top and bottom if there's something I can reduce. And in this case, now 4 and 13 you can't reduce, but you can reduce 5 and 20. Good. 5 will go into itself one time and into 24. Good. So if you need to rewrite 4 over 1 times 4 over 13, you should be able to see that that's 16 over 13. Do y'all see that? And it doesn't reduce. Leave it as an improper fraction, okay? Nine x to the 4th over 3x to the 5th divided by 3x squared over 5x to the 3rd. So the very first thing we're going to do is flip that second one, okay? So we're going to keep 9x to the 4th over 3x to the 5th, change it to multiplication, and there we're going to put 5x to the 3rd on top and 3x to the 2nd on the bottom, okay? And then what? 9 and 3, now you can do one or the other way. It doesn't matter. You can either do the top and bottom, because then you see that's 9 over 3 right there, or you can go diagonally. You got 9 and 3. So either does not matter, okay? So we're going to do top and bottom. I'll reduce top and bottom. 3 will go into itself one time, but it will go into 9 3 times, okay? Now, I'm going to rewrite it. That's going to give us 3x to the 4th over x to the 5th times 5x to the 3rd over 3x squared. Now, looking at it, are you through reducing? Now, what else can you reduce? The 3's. Good. Do you see you got to double reduce? And that happens sometimes. So we can continue to reduce and cancel out the 3's. Does that make sense? So now we have on top, you got a whole number 5. Do y'all agree? I'm bringing it together. Y'all see, I don't want to rewrite it again. I'm going to bring it together, top times top, bottom times bottom. So that would give me 5 But since I'm in multiplication and I got x's on both tops, what do? Add them together. Very good. So that gives me x to the 7th. And on the bottom, that would give us x to the 7th. Okay? And what happens? Add x to the 7th to what? Cancel. They cancel out because 7 minus, even if you do the subtraction, 7 minus 7 is 0. Right? So that's the same thing on top and bottom. So it cancels. So your answer is just who? 5. Do y'all see that? Take your time and show all your steps because you don't want to leave somebody off. Okay? Do y'all see that? Okay. Number 5. 5x minus 15 over 3x plus 9 times 4x plus 12 over 6x minus 18. Now, these are the ones that I normally like to put on test because this is making sure you are remembering what you were just tested on. Which means the way that you break this stuff down before you do any type of canceling is you're going to have to do some type of factoring. Does that make sense? Now, this one should, if you look at each top and bottom, can be worked separately. But on this particular example, I gave you all GCF. Does that make sense? Each top and bottom has a GCF you can pull off. But you could have GCF, difference of squares. I don't want you to think they have to match. All right? So, on the top of the first fraction, what's the GCF? 5. So if you take it off, we're left with x minus 3. Good. On the bottom, what's the GCF? 3. Good. Take it off, what's left? X plus 3. Good. Times on the top of the second one, what's the GCF? 4. Take it off, what's left? X plus 3. Good. And on the bottom, what's the GCF? 6. Take it off. What's left? X minus 3. Very good. Do y'all see that? Now, you do some type of your reducing. Yeah, you're canceling. So obviously, we can cancel out the X minus 3's and the X plus 3. Okay? What else can you reduce? 4 and 6. Good. Now, they both have who in common? 2. So that would make a 2 on top and a 3 on the bottom. Do y'all see that? So, if you need to write what's left, if you need to see it clearly, you just have whole numbers left. Does that make sense? 5 over 3 times 2 over 3. And nothing else reduces, so just multiply, and that's what? 10 over 9. Do y'all see that? Questions? That one's okay? Okay. Let's do 4x plus 16 over 10 divided by 3x plus 12 over 18. First thing we're going to do is what? We got to flip this second one because this is division, right? So I'm going to flip it, but if you need to rewrite all of it, that's fine. But I'm going to go ahead and reduce the first one, and when I get to the second one, I'll flip it. Does that make sense what I'm saying? That's just to save me from doing a lot of writing. So on this first top, what are we gonna do? GCF of 4 in it. So when you take it off, what's left? 4, what's left? X plus 4, right? Okay. And that's over 10. Change it to multiplication. Now, who comes to the top? 18. Now on the bottom is that 3x plus 12, but go ahead and simplify. What can you do with 3x plus 12? Take off 3, and what you say is left? X plus 4. Good. Y'all see that? Okay. So now we do our canceling, our reducing. So we can reduce, obviously, the x plus 4s. Okay. And so that gives us 4 over 10 times 18 over 3. What else can be reduced? Okay, you want to reduce 2, which one? 4, you said 4 and 10 or 10 and 18?
Why would we just do 4 and 10 and then 18 and 3? Wouldn't that be-
That's what I would do. Because does 3 go into 18?
Yeah.
Yeah, so I would do 4 and 10 and then turn around and do 18 and 3, okay? So 4 and 10, when you reduce it, you get 2/5, 2 over 5, good. And when we reduce 3 and 18, you get 6 over 1. So let me write this over. You got 2 over 5 times 6 over 1. Are we done reducing? Yes. So multiply that out. That's 12 over 5. Very good. Yeah, I see that.
But had we not done it, reduced it the way we did and reduced it the other way, would it still come out the same answer?
Yes, if you would have reduced what you said, the 10 and the
Like if
18.
10 and 18.
Okay, let me go to another. Let me flip over. That's what? 4 tenths and 18 thirds. 4 tenths times 18 thirds. Okay. If you would have reduced it 10 and 18, that would reduce by what? 2? That would give us what? 5 and 9, right? So we got 4 over 5 times 9 over 3. Exactly. You just have to keep going. 9 over 3 will reduce with 1 and 3. So you got 4 over 5 times 3 over 1, which is still 12 over what? 5. Does that make sense? Right. Either way, you just got to remember to keep going if you still see something in common. Does that make sense? Yeah, either way would have worked. So I'm glad you pointed that out so everybody would know. It does not matter how you reduce it as long as it's a top and a bottom. You can never do 2 tops and you never can do 2 bottoms. It has to be a top and a bottom. Okay? Does that make sense? Okay. Good deal. Let's do... I might have to get my other textbook. I don't like none of these problems. What number was this? Number 7. X squared plus 4x minus 5 over x squared plus 7x plus 10 divided by x minus 1 over x plus 4. Okay. So we do know we're going to flip the second one, right? Because it's division. But we're going to tackle this first fraction first, which is nothing but factor and a trinomial. Does everyone see that? That's just two trinomials. So that means you're going to have two parentheses on both the top and bottom. Does that make sense? So just looking at the top one, we are subtracting to get 4, and we don't have a one choice. 5 and 1, X is in the front, 5 and 1 in the back. Now make sure you got your signs right. So if 4 is positive, if I'm subtracting, who has to be positive? My 5. 1 is negative. Does that make sense? And then on the bottom, we're adding to get 7. So we're obviously going to use from 10, 5 and 2, and 7 is positive, so they're both positive. Do y'all see that? Then change it to multiplication, and who's on top? Good. Then x minus 1 on the bottom. So who cancels? Good. X minus 1 and the x plus 5s. So left on top, you got x plus 4 over what's left on the bottom? X plus 2. Awesome. And that's your answer. Y'all see that? Questions? Can I reduce? No. I was glad somebody said that. No. You cannot reduce 4 and 2. Because 4 and 2 are married to x. Y'all see there's a plus sign there. Okay? If they were single, and what I mean by single is you would have to have, my pen like it don't want to write. You would have to have x and 4 on the top by itself and x and 2 down on the bottom by itself. Now that's single, so yeah, you could cancel out the x's and you could reduce 4 and 2 as 2 over 1. But you cannot do that if you got a plus or minus sign in between it. Does everybody understand that? The only way you can cancel out, I always call them married or couples, is you cancel the whole couple out. Does that, you see, like we did up here. The 5x, the 5 plus x, x plus 5, I'm so backwards, and the x minus 1, you cancel the whole unit out. Does everybody see the difference? But if there's a plus sign or a minus sign in between them, you just can't go up and start, having conversations with, that's a married unit, okay? So keep it together unless you cancel the whole thing out. Does that make sense what I'm saying? Okay. Good question. All right. Number 8. Two x squared minus 5x minus 12 over x squared minus 10x plus 24 times x squared minus 9x plus 18 over 4x squared minus 9. And honestly, I like to look at all my tops and bottoms and make sure I know what I'm doing. Now, this first fraction, top and bottom, is just a trinomial. We're going to factor. Okay, the top of that second fraction is also just a trinomial. But what's on the bottom of it? Difference of squares. Do y'all see that? So we got a little mix up. So we're going to take each piece separately. Okay, so look at the top of that first fraction. You don't have a GCF. I always ask myself that, okay? Don't ever rule out GCF. But 5 makes you not have a GCF. So you're going to have to use the front number as well as back numbers. Does that make sense? So we are subtracting to get 5. And I have to use a 2x and a 1x in the front. Now, we've had this conversation, but I will write this down. You got 1 and 12, 2 and 6, and 3 and 4. Now, who you can't use? 2 and 6, why? Right, they're both even, and now one of them can sit with two. So you gotta remember those rules for factoring. And 1 and 12 gonna be too much, because 12 gotta sit across from 2. So that kind of helps you eliminate that you can only use 3 and 4, and you can only do it one way. 3 gotta be in the parenthesis with the what? With the 2. But I want you to take your time. Go over to the side. Check your outside and inside to make sure this factor's right. Outside is 8x, inside is 3x. Does that give you 5? Yes. So 5 is negative. So that means my 8x got to be negative. My 3x is going to be positive. Go to the side and check that out, okay? Now my bottom, we're adding to get negative 10. And this time I can just throw x's in the front because I don't have no number in the front. So I'm specifically looking at the factors of 24, which you know it ain't going to be 1 and 24. You got 2 and 12, you got 3 and 8, and you also got 4 and who? 6. So which one going to add to 10? 4 and 6. Stick them in the back. And since 10 is negative and we added, they both got to be what? Negative. Do you see that? This is the reason why I'm stressing so hard with the factoring. You gotta know factoring, because you'll skip this whole problem because all of this is factoring. The concept in this section is just canceling it out. Factoring you're gonna have to know. Okay, we go to the top, times. Got our 2 parentheses. We're adding to get 9. And with 18, you got 2 and 9, but you also got 3 and who? 6. So which one we using? 3 and 6. And again, if we adding and he's negative, they both got to be negative. And then on the bottom, we got the difference of squares. So that's just going to be 2x plus and minus who? 3. Very good. Y'all see that? Now the easy part is canceling. So you would cancel out x minus 4, who else? X minus 6 and 2x plus 3. Good. So we have left on top x minus 3 over, very good, 2x minus 3. Yeah, I see that. Questions? Okay. M squared plus 2mp minus 3p squared over m squared minus 3mp plus 2p squared divided by m squared plus 4mp plus 3p squared over m squared plus 2mp minus 8p squared. And so we know with division, this one gonna have to be flipped. But just looking at every top and bottom, I got 3 terms. So this is just trinomials, right? And also I want you to notice that you're going to have variables in the front as well as the what? Back, okay? So it might just be helpful. Make that a multiplication. And it looks like, don't they all got m's in the front? P's in the back. I would go ahead and stick them in there, because half you're going to leave them off. I see that so much on tests. Just stick them in there. Now we go back and get our numbers right. Does that make sense? Go ahead and stick them M's and P's. M's in the front, P's in the back. So if we go to that first fraction top, we're subtracting to get 2. That's really easy. We don't have but 3 and 1, right? And who's going to be positive? The 3. 1 is negative. Okay, that bottom, we're adding to get that 3. So we got 2 and 1, and they're both what? Negative. Right? Okay. Now we flipping. So I'm looking at the bottom to put on top. Y'all follow me? Okay. So m squared plus 2mp minus 8p squared is what I'm looking at. So we are subtracting to get that 2. And we're going to use 4 and 2. And since 2 is positive, who's got to be positive? The 4. 2 is negative. Good. And that top is your new bottom. And so we're adding, and that's going to be 3 and 1, and both positive. Awesome. Do y'all see that? Good deal. So who cancels? M plus 3p? Okay. M minus 2p. And who else? And M minus 1p or M minus p? Right? So we're left with on top M plus 4p over M plus 1p. Or you can say p, can't you? Yeah. Either one. Questions? Number 10. AC plus AD plus BC plus BD over 2, no, erase that, not 2, over A squared minus B squared times A to the third minus B to the third over 2A squared plus 2AB plus 2B squared. What's that on the top of the first one? Grouping. Okay? We wanted to find an example to kind of show you that I can use any type of factoring method. Okay? So that's grouping. Now, I don't have to rearrange it, right? So, off the first 2, you can take off an A, and what's left? C plus D, right? And then off the second 2, you can take off a positive B, and what's left? C plus D. Good. So, I'm going to write it down here. That top gives you the 2 parentheses of A plus B and C plus D. And you know it doesn't matter which one you write. Y'all see that? That's how we do grouping. I just grouped it up there on the top of it. I'm trying to save and rewriting over and over, but that's the answer when I wrote it right there. Okay. Now that bottom, sometimes, like I said, I think I said this earlier, it's harder to see because your numbers in front of your variables are ones. But that is the difference of squares. Good. So that's just going to be A plus B and A minus B. Very good. Do y'all see that? Times. Now, what's that bad boy on the top of the second one? That's a difference of cube. That's a difference of cube. Okay? So, the way we do cubes, you got a smaller parenthesis, which is just going to be the root, which is just who? A minus B, right? Because you have no numbers up there but 1. So, it's just A minus B. And to get that second parenthesis, we're going to square, multiply, square. Good. So if you square A, that's obviously just what? A squared. Good. Multiply it together, that's AB. And then if you square B, that's B squared. Only one negative, so my signs would be what in the second one? Positive. Good. Plus, plus. Do y'all see that? Look at that bottom on the second one. What's the only thing you can do there? I want you to look at it. Don't go too deep, Mona. Look, I need you to look at it. Greatest common factor. Don't you see that all three terms got a 2 on it? Take the 2 off. If you take the 2 off, you're going to have A squared plus what? AB plus B squared. Don't try to tackle that because it's the same as the one on what? On the top. So you see that's going to cancel out. Do y'all see that? That's why I was wanting you to see the small obvious was that they had a 2. Don't try to factor that now. For one, it's not going to factor. But I needed you to just see the 2 and obviously see that it's matching that long one on top. So it's going to cancel. Okay? So it's going to cancel that out. We know that's the same thing. That cancels. What else cancels? A plus B. What else? A minus B. Good. So what's left on top? C plus D over 2. Very good. Y'all see that? Okay. Number 11. X to the third plus y to the third over x to the third minus y to the third times x squared minus y squared over x squared plus 2xy plus y squared. So obviously on this first fraction, you got cubes, right? So the top, the root in that first parenthesis is going to be who? X plus y. Good. And then we're going to square, multiply, square. So square x's, multiply together, and square y. Very good. And so the signs will go, because that's a plus in the front. Negative, positive. Very good. Okay. On the bottom, you got the same type of setup, but my signs are going to be different. Does that make sense? You got a cube, and the root is going to be x minus y. But my terms are going to be the same. You're going to have x squared xy, and y squared, but what's the sign she said? Positive, positive, good, because you could only have one negative. Times, now what's that top? The difference of squares, so that's just good, x plus and minus y. And then on the bottom, now this thing factors, because that's the understood 1 in the back, right? Can 1 add up to 2? Yes. So we're going to stick x's in the front, stick y's in the back. Now you can stick that 1 there if you want to, but it's kind of understood, and make both of them positive, right? Because 1xy plus another 1xy is 2xy. So here, who cancels? Well, we got x minus y, and you can do diagonally a x plus y, and top and bottom a x plus y, right? So we're just left with good job. You're left with that second parenthesis off them cubes. X squared minus xy plus y squared over x squared plus xy plus y squared. Does that make sense? Questions. Now I pulled my other book out because I know it had some cube examples, but I wanted to give you an example to show that I can utilize almost everything we've done in factoring and stick it on these problems where you have to reduce it by factoring it, then cancel. Do y'all see that? That's the reason why I'm still stressing if factoring is an issue, you gotta get some help with factoring because this whole test got factoring on it. Still. It doesn't go away. Do you have any questions? And that's going to be my last example with 7.2. Do you have any questions on 7.2? No?